discussed about path of a projectile and projectile motion. Okay, this topic is continuation from the same topic. Now in that class I have drawn a projectile motion. I just draw a rough diagram, not the same as in the previous diagram, but you don't have to draw this, just refer to the previous diagram. Okay, so there was a projectile motion. A body was moving in a path like this. Okay, this was a part of the motion. O, and this was the range of the projectile. This was the maximum height of the projectile. Okay, this was given. Now, in today's class, we will discuss about flight time of a projectile. Flight time of a projectile means time taken for an object to reach from this point, initial point, to the final point. That is the time taken for a projectile. So, first of all, you can write down time t. Time is equals to t. This time is taken to reach point P. Now, which is the point P? P is over here. That is the maximum height of the projectile. So, time is equals to t to reach the point P. Next is, now what we know at this point, what I have told you is vertical velocity, upward velocity is 0. So, vertical velocity at P is equals to 0. Okay. So, what we have seen is, while in the projectile motion, horizontal velocity remains the same. There is no change in the horizontal velocity. It is same throughout from initial to the end. That I have told you also. But vertical velocity, it constantly changes from one point to the other point. That is the vertical velocity. So, we are going to derive this equation in terms only of vertical velocity. We are not going to use the horizontal velocity. Okay, horizontal velocity as it is same. Now, vertical velocity at point P is 0. Vertical velocity, that is Vx, is 0. Now, initial velocity, that is vertical velocity, component of vertical velocity along y-axis. Uy, I hope you know this. We have written this before also. Uy was u sine theta. What we have done is, we have resolved a vector, velocity vector into two components, x and y. So, y component was u sine theta. Now, there is one equation of motion. We are going to use the equations of motion. If you remember, one of the equation of motion was v is equal to u plus a t. Now, u was final velocity, u is initial velocity, v final, u initial, a acceleration due to gravity, t is the time. Now, in this situation, what changes is, acceleration due to gravity acts downward. Your projectile motion is acting upward. Okay, it is acting against the acceleration due to gravity. So, this we can write it as u minus a t. V is equals to u minus a t. Why minus? Because the motion is against the gravitational force. Next, what was our V? Vertical velocity, that is the final velocity at this point. Final velocity at this point is 0. Initial velocity at this point, initial velocity was u sine theta minus, in place of a, I am writing g. Okay, it's the same. A and g, it is acceleration due to gravity. You can write any, that is a or g, but in the previous derivation I have written g, so we will continue with g. Now from here, we take this towards the left side. Gt is equals to u sine theta, and t is equals to u sine theta by g. This is the time taken to reach from point O to point P. Now, the same amount of time is taken to reach from point P to the final point over here. So, the total time denoted by T is equals to twice into small t, because to reach from this point to this point and this point to this point takes the same amount of time. So 2 for t will give us the total time, which is the flight time of a projectile. So this gives 2u sin theta divided by g. This is the total flight time of a projectile. Okay, this is the first one. Second, we will derive height of a projectile, which is this h. Whatever I am writing in the board, please note it down. You please note it down. This will be the notes also. I am not going to give you separate notes, just write it down, whatever I get you to write and whatever I write in the board. Second, what I am going to derive is height of a projectile. Height of a projectile means the maximum height of the projectile, that is h. So h is equals to vertical height of a projectile, which we are going to derive. Now again at this point P, your vertical velocity, that is v, is equals to 0. Now again using the equation of motion, which is v squared is equals to u squared plus, in place of plus I am writing minus because the motion is against the gravitational force, minus 2gh. This is the second equation of motion. Now in place of v, what we can write? 0. In place of u, what was our u? Like previous case, u sin theta naught. So it is squared, so over here it will be squared, minus 2gh. Okay, so rearranging this, taking this part towards the left hand side, 2gh is equals to u squared sin squared theta naught, or h is equals to u squared sin squared theta naught divided by 2g goes over here in the numerator. So this is the height of the projectile h. Now, in which case, in which situation will the height become maximum? For this h to be maximum, it totally depends upon sin theta. So what is the maximum value of sin theta? 1. So in which situation sin theta becomes 1? When theta is equals to 90 degree, h will be maximum. So when theta is 90 degree, h will be maximum. So if you want to throw an object upward till it reaches its maximum height, we have to throw it in a 90 degree angle directly up, that is directly perpendicular to the surface. Then the height of the projectile becomes maximum. Right? This is the case. Now the third topic, that is the range of the projectile. We are going to find the range of the projectile, that is r. If I am speaking too fast, please do pause the video, and there is an option to slightly slow down the video. Please do that and make the notes. Range of a projectile. We are going to find this r. Again, what is our range? O to this point. Okay. How far the object is moving, that will be the range. So how do we find the range r? What is this range? Range is distance. Now what is the formula for distance? Distance is equals to velocity into time. Which velocity we are talking about? We are talking about along x-axis. So x-axis is the horizontal velocity into time. Which time? Time of flight, or flight time of projectile. I hope this is clear. Distance is equals to velocity into time. Just rearranging this. Now, r is equals to, what is horizontal velocity? It is u x time is capital T. Now ux in the first class I have written, in the first class of this projectile I have written this. It is u cos theta. Just below the diagram, in previous diagram, just see in place of ux we have written u cos theta. T was just we have derived. It is 2u sin theta naught divided by g. We'll rearrange this. U into u square. 2 sin theta cos theta divided by g. Now I hope you know the formula for sin 2 sin theta cos theta. 2 sin theta cos theta is equals to sin 2 theta. Okay, so we write u square in place of this sin 2 theta divided by g. This is the range of a projectile. Okay, range of a projectile. So now from this part we can assume or we can find out at what angle if you throw this object, how far an object can go. What can be the angle to make the object move far? So for that, in which situations will the range be maximum? So look at this equation. In which situation will the range be maximum? When, so we can write down for maximum range, that is R. For maximum range, this 2 sin theta, sin 2 theta should be 1 because the value of sin theta maximum is only 1. It cannot go above that. So in which case, in which angle theta is 1? When this angle is 90 degree. When angle which is 2 theta is 90 degree, sin theta is maximum. So from here theta is 90 by 2, which is 45 degree. So this was your theta. If you throw an object at an angle of 45 degree, the range of the object will go far, it will be maximum. So it depends on this equation. So in which condition the range will be minimum? When sin theta becomes 0. At which situation sin is 0? When theta is 0 degree. So if you throw just directly without picking an angle with the surface, then the range will be very small. If you throw at an angle of 45 degree, the range will be maximum. Okay, the range of an object will be maximum. In your book, there are a few examples. You can go through that by yourselves. And from this particular chapter, we are covering till this topic only. There is a small topic after this which we are just exploding because a lot of syllabus has to be covered. So this till year only, this is an important part. We are covering up to year only. And from in the next class, I will do few numericals and then start a new chapter. So if you are confused with the syllabus, because small topics which are there in the book, we are just skipping the topics and trying to cover the maximum number of chapters. Okay, so if you are confused, just go through the topic in the book and try to understand it. If you have any confusion, I am always there to help you. Please do contact me. Okay, this much for today. Thank you.